Hey guys, you are watching video about heat transfer analysis and fluid structure interaction solution in APM Multiphysics. We have horizontal shell and tube heat exchanger. What we're gonna do? First of all, we do CFD analysis of turbulent flow fluid and gas in heat exchanger using APM FGA, and then fluid structure interaction analysis. Okay, let's start with import geometry in APM Studio. Load 3D model in step format. The heat exchanger consists of three areas: steel, gas, and water. So we have to create three material. We will just create three material with default material properties and apply appropriate material to each area. Before generate mesh, we have to define contact zones. Since the model is an assembly, we have to set coincident faces. For FSI analysis, we need to choose coincident mesh. So select this option and start automatic detection of model coincident faces. We've got coincident faces. Next step is mesh generation. We need to edit mesh parameters. So apply 4-node tetrahedrons and set length of element side is 10. We got finite element model of heat exchanger, and now we're gonna transfer this model to APM structure 3D for further analysis. Our model loaded into the APM structure. Layers were created for each area of the model. Let's go to Edit Material Properties. We have to apply flow properties for each material for CFD analysis. There are 4 constants need to be set: density, viscosity, specific heat, and thermal conductivity. When material parameters are determined, we proceed to setting the boundary condition. for CFD analysis. Let's begin with water area. We will turn off other layers and display only water. We need to set inlet and outlet boundary conditions. Click on Loads, select FGA boundary conditions, rename this boundary condition. Now we're gonna select surface for inlet and specify mass flow rate. Then we need to set inlet temperature. On outlet, we set static pressure. Now we go to setting boundary condition for gas area. The same way, we're gonna apply mass flow rate and temperature on inlet and pressure on outlet. Next boundary condition on symmetry plane. Apply velocity on normal direction and define as 0. Now we have to set the boundary condition on all other walls. All components of velocity are equal to 0. It simulates no slip conditions. Next step is setting boundary conditions for static analysis. We need to apply supports of heat exchanger. For first support, we lock all translation degree of freedom. For another support, lock only 2 direction. And finally, set symmetry boundary condition as lock normal translation. Before starting CFD calculation, we should edit Navier-Stokes flow analysis options. Formulation of the problem is thermal and turbulent. Convergence criteria set as all residuals should be less than 0.301. And run analysis. FGA monitor displays level of residuals on each iteration. The calculation goes until the residuals reach their required level. Solution is done. Let's see result of CFD calculation. First, we look at the flow velocity fields. Select layers and turn off still area and water area. And we will see flow velocity on gas area. The same way we can display flow velocity on water area. Postprocessor has a tool to set the cut plane for view result inside area. Also, we can use leaders to display the value of results at any point. Now go to output pressure field. Here is static pressure field. We see pressure drop from inlet to outlet. And finally, display temperature field. Now we're gonna do FSI analysis. So we run linear static analysis and take into account pressure and temperature fields from FGA analysis. Run calculation and let's see result. Display stress, choose map position undeformed model. The maximum is on branch pipe. Next, we'll see displacement on deformed model. There is deformed model with scale factor. So we've got stress-strain state caused by temperature and pressure fields. Thanks for watching this video.